years before that project becomes a reality. If it goes as planned, the journey to Proxima B will take about 20 years.
We have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find because it's the nearest star to the Sun.
A journey to Proxima B may take 20 years, but it's a trip worth considering.
What makes Proxima B interesting is that it's an Earth-like planet orbiting the nearest star to the Sun.
This planet is definitely the closest planet to the Sun that's not orbiting the Sun.
Recently, this exoplanet has caught the attention of scientists due to strange light emissions that challenge everything we know about the cosmos. Could this be proof of alien technology? With its Earth-like qualities, Proxima B is emerging as one of the most exciting possibilities in the search for life beyond our planet.
Is there another planet that's very close to Earth, kind of like us, where there could be a civilization?
Yeah, I mean, the closest star system to us, Proxima Centauri, actually has a fairly Earth-like planet around it. We don't know quite how Earth-like it is, but it's called Proxima B.
Earth's distant cousin with a twist. All right, let's take it from the top. Proxima B is a planet that's pretty close to Earth in size. That alone makes scientists sit up and pay attention. When a planet is about the same size as Earth, people start to wonder if it could also have Earth-like conditions. Maybe, but not so fast. Proxima B doesn't orbit a star like our Sun. Instead, it circles a red dwarf star called Proxima Centauri. This star is smaller, cooler, and gives off way less light than the Sun. That's important because the kind of star a planet orbits affects its weather, its temperature, and whether it might support life. Now here's the exciting part. Proxima B sits in what's called the habitable zone. That's the not too hot, not too cold area around a star where liquid water could exist. And let's be real, if you're looking for life, water is usually step one. But don't pack your bags just yet. Proxima B comes with some serious challenges. First off, it's probably tidally locked. This means one side of the planet always faces the star, and the other side is stuck in eternal night. Imagine living on a planet where one half is burning hot all the time, and the other is frozen solid. Not exactly cozy. And if that wasn't enough, Proxima Centauri is a bit of a drama queen. It shoots out powerful solar flares, huge blasts of energy that can slam into Proxima B. These flares might strip away the planet's atmosphere or make life on the surface pretty dangerous with all that radiation. Still, despite all that, scientists are very interested in Proxima B. Why? Because it's one of the closest Earth-sized planets we've found, and it might just have some liquid water. That makes it one of the best places to look for life beyond our solar system. Red dwarf. Okay, let's talk about something that doesn't sound all that exciting at first. Red dwarf stars. They don't glow brightly, they're not massive like some of those giant stars in space documentaries, and they definitely won't win any most dramatic awards in the universe. But don't let that fool you. Red dwarfs are actually kind of a big deal. First off, they're the most common type of star in our galaxy. So if you just picked a random spot in space, chances are there's a red dwarf nearby. These stars are small, dim, and burn their fuel very slowly. That slow burn means they can keep shining for billions, and sometimes even trillions of years. That's important because if a planet is orbiting one, it has a long time to just be there, which is a good thing if you're hoping life might develop. Because red dwarfs are cooler than our Sun, their habitable zone, the area around the star where liquid water could exist, is much closer in. That's where planets like Proxima B come into the picture. Proxima B orbits Proxima Centauri, which is a red dwarf. And lucky for us, it's sitting right inside that habitable zone. So even though the star is dim, it could still be warm enough for water. And where there's water, there might be life. Now let's talk about Proxima Centauri itself. It doesn't shine brightly, actually. It only gives off about 0.0005% of the visible light our Sun gives. That's barely anything. But because Proxima B is really close to it, the planet still gets about 70% of the infrared energy that Earth gets from the Sun. So even if you couldn't sunbathe there, the planet might still be warm enough to matter. However, there's a twist. Proxima Centauri is known as a flare star. That means it has a temper. It can suddenly brighten up to 100 times more than usual, blasting nearby space with intense radiation. Those sudden flare-ups could be harmful to anything trying to live on Proxima B. All that radiation might mess with the planet's atmosphere, making things less friendly for life. Strange signals. Back in 2020, scientists from the Breakthrough Listen project picked up a strange radio signal coming from the direction of Proxima Centauri, the closest star system to Earth. The signal, called BLC1, got everyone buzzing. It wasn't random static. It had a narrow bandwidth and a drifting frequency, the kind of stuff you'd expect from a deliberate transmission. Naturally, people began wondering, could this be aliens? But then, just as quickly as the excitement started, the experts said, nah, it's not aliens. It's probably just radio interference from Earth. And just like that, the story died down. But here's the thing, that explanation doesn't totally make sense. Let's break it down. First off, the signal came from a very specific point in the sky, right where Proxima Centauri is. Most radio interference from Earth shows up all over the place or repeats in different parts of the sky. But this one, it was focused, and it didn't pop up again during follow-up observations. That's weird. If it were truly just human-made interference, why did it seem so directed? And why did it only show up once? Also, the signal didn't match any known satellite or Earth-based source. The frequency drift, which is how the signal slowly changed over time, is something you'd expect from a transmitter on a rotating or moving planet, like, say, a planet orbiting Proxima Centauri. That detail got swept under the rug a bit too quickly. The official explanation is that BLC1 was caused by some sort of human-made device, maybe a phone tower, maybe something else. But they still haven't identified exactly what. So we're just supposed to accept that this rare, focused, once-in-a-lifetime signal was a fluke. Even some scientists admit the whole situation was a learning moment for an organization called SETI, which stands for Search for Extraterrestrial Intelligence. They say it helped refine their process. Fair enough, but brushing off the possibility of aliens just because we think it's interference, that seems a little too easy. Alien life. Imagine waking up to the news that scientists have finally detected alien life or advanced technology on Proxima B. The headlines would explode. It wouldn't just be about finding something interesting on another planet, it would change how we see ourselves in the universe. It would confirm that life can exist in environments very different from Earth's, which means Earth isn't so special after all. That alone is mind-blowing. But it gets deeper. If we also found signs of alien technology, it could shake up everything we know about science, engineering, and even human progress. Think about it. If another civilization developed completely different technologies, we might be able to learn from them, borrow from them, or even use their discoveries to fast-track our own advancements. It's a wild possibility, but right now we're still at the beginning of the journey. The only way to get answers is to keep exploring. Scientists are pushing boundaries every day, using powerful telescopes to study Proxima B from afar. And what they've found so far only adds more layers to the mystery. One of the most fascinating things about Proxima B is how it's tidally locked, meaning one side always faces its sun, while the other side is stuck in permanent darkness. That creates insane temperature differences. One half is constantly baked in sunlight, while the other is frozen in eternal night. Life in those extremes sounds impossible, right? Maybe not. There's a narrow strip between the two sides called the twilight zone, and this might just be the sweet spot. Temperatures here could be stable enough for liquid water to exist. And if there's water, there's a chance for life. On top of that, strange signals from the planet's dark side have made scientists wonder, are they coming from something or someone? Are we hearing the whispers of another civilization across space? Giant eye in the sky. Proxima B orbits a red dwarf star named Proxima Centauri, which sits over 4 light-years away from us. That's about 25 trillion miles. To give you an idea, even the fastest spacecraft humans have ever built would take tens of thousands of years to get there. So right now, all we can do is study it from afar. One major problem? Our tools. Regular telescopes can't clearly see planets that are far away, especially when the planets are right next to a bright star. Imagine trying to spot a tiny firefly next to a huge spotlight. That's what it's like trying to spot Proxima B. That's why newer and more advanced tools are such a big deal. Take the James Webb Space Telescope, for example. It can detect infrared light, which helps us peek at distant planets and maybe even figure out what's in their atmospheres. Then there's Harmony, an advanced tool being built for the extremely large telescope. This telescope, set to open in 2028 in Chile, will be the biggest of its kind, with a mirror almost 40 meters wide. That size means it can collect way more light and produce super sharp images. Scientists hope the ELT will do something groundbreaking. Look at the light reflected off Proxima B and find signs of life. By checking that light from molecules like oxygen, carbon dioxide, or water vapor, it could tell us if something is living there. A 2025 study even suggests the ELT might be able to tell the difference between living and lifeless planets in just 10 hours of observation. That's a massive leap. Proxima B remains one of our best chances at finding life beyond Earth. The new technology is finally giving us the power to study it like never before. If Proxima B does have an atmosphere, and especially if that atmosphere has signs of life, the ELT might be the telescope that spots it. And if that happens, the question, "Are we alone?" might finally get an answer. Elon Musk sets his sights. Elon Musk has done it again. After creating the world's first reusable rocket through SpaceX, a move that completely changed the way we think about space travel, he's now turning his attention to a planet outside our solar system, Proxima B. But first, a quick look at SpaceX. Founded in 2002, SpaceX was Musk's big leap into space exploration. The company's goal? To make space travel cheaper and faster, and eventually send humans to Mars. One of their biggest achievements was building rockets that don't get thrown away after one launch. Instead, they can land, get cleaned up, and fly again. It's like making airplanes reusable instead of tossing them after every flight. This breakthrough saves millions and opens the door to longer, bolder missions. Now, Elon's always had his eyes on Mars, but something new just grabbed his attention. This planet called Proxima Centauri B. That may sound super far, but in space terms, it's practically in our backyard. So why is Proxima B getting so much buzz? Because it's located in the Goldilocks zone. That's the area around a star where the temperature is just right. Not too hot, not too cold, meaning liquid water could exist. And where there's water, there might be life. In 2018, NASA scientist Anthony Del Genio and his team ran computer models to figure out if Proxima B could hold water on its surface. Their findings showed it's actually possible, and that got Elon Musk talking. He tweeted about it, calling the planet practically next door. Some of the newer models even suggest Proxima B could have oceans that are 200 kilometers deep, much deeper than anything on Earth. With Elon already building rockets that can fly again and again, and the technology improving fast, it's not crazy to imagine a future where SpaceX isn't just sending satellites like Starlink into orbit, but actually planning trips to study nearby exoplanets like Proxima B. Could it really be our second home? It's too soon to say, but Musk's interest in the tech behind SpaceX might just make it possible someday. Can we really get there? So here's the big question. We've found a planet that might be habitable, Proxima B, and Elon Musk is excited about it. Scientists say it might even have deep oceans and sit in the perfect spot for life. But the real problem? Getting there. Let's talk distance. Remember, we said Proxima B is over 40 trillion kilometers away. That's not just far, it's crazy far. To put it in perspective, Voyager 1, the fastest spacecraft we've ever sent out of our solar system, would take 80,000 years to get there. Yeah, that's longer than humans have had written history. So how could we possibly reach this planet in our lifetime? This is where NASA's DEEPIN project comes in, short for Directed Energy Propulsion for Interstellar Exploration. This is where things get exciting. Instead of using regular rocket fuel, scientists are working on tiny spacecraft that could be pushed by powerful laser beams from Earth. Think of it like sailing across space using light instead of wind. These sails are super thin and light, and when hit by lasers, they could go unbelievably fast. Some say they could reach up to 20% of the speed of light. That means we could reach Proxima B in just 20 years instead of 80,000. That's within a human lifetime. But here's where Einstein comes in. Remember Einstein's theory of relativity? One part of that theory is time dilation. And it's not just science fiction, it's real. Basically, the faster you travel, the slower time moves for you compared to someone standing still. So if you were on one of these super fast spacecraft heading toward Proxima B, time would pass more slowly for you than for people on Earth. For the astronauts on board, the trip might feel even shorter than 20 years. It's wild to think about. Einstein showed that time isn't fixed. It changes depending on how fast you're moving. That idea, once only a theory, now has real uses in space travel. GPS satellites actually adjust their clocks using this principle, so it's already part of our everyday tech. Now, it might help us reach other stars, so between SpaceX's reusable rockets, NASA's Deepen project, and Einstein's time-bending science, the dream of visiting Proxima B is starting to look a little less like science fiction and more like a future waiting to happen. Terraforming Proxima B. Okay, so let's say Elon Musk and the folks at NASA actually get us to Proxima B. Cool, right? But it's not exactly welcoming. Turns out, even if we make the trip, the real challenge is just beginning. We'd need to terraform the place. Basically, we'd have to remake the planet so it could support human life. One of the biggest issues is tidal locking. Proxima B is so close to its red dwarf star that one side likely always faces the star, so it's stuck in constant daylight, while the other side is in permanent darkness. That means extreme heat on one side and freezing cold on the other. But scientists think we might be able to fix that with technology. One idea is to create an artificial magnetosphere, sort of like a giant invisible shield, to protect the planet from the star's powerful radiation and solar flares. Earth has one naturally, but Proxima B might not, so we'd have to build it ourselves. Another step would be to change the planet's atmosphere, either by pumping in greenhouse gases or setting up artificial clouds to trap heat and spread it more evenly. There's also the issue of that super cold dark side. To make it livable, we'd have to figure out how to move heat from the hot side to the cold side, maybe with huge underground pipes, engineered ocean currents, or high-tech vents. If the planet has oceans, they could actually help out by carrying heat naturally. Salty water freezes at a lower temperature, and the currents could move warmth around. We could even install artificial lights on the dark side, powered by solar panels on the sunny side, or orbiting mirrors to give plants and people enough light to survive. And to pull all of this off, we'd need help, lots of it, from AI. Artificial intelligence could run climate models, adjust systems as the environment changes, and even manage the construction of our new home, one machine-built building at a time. So yeah, terraforming Proxima B is no small task. But if we want to live there, we might just have to turn science fiction into reality. Was there life before? There's a theory floating around, and it's one that sounds like something straight out of a sci-fi novel. Some scientists have suggested that Proxima B might have once harbored life. Of course, their story is that volcanoes, freezing oceans, and harsh temperatures erased it all. Before it got stuck in its tidal lock, before its oceans froze, and before those super hot volcanoes erupted again and again, this planet could have had a much friendlier environment. But over time, things went sideways. Proxima B is so close to its star that one side of the planet gets blasted with heat, while the other side remains in a permanent, icy darkness. In the past, though, it might have had a more stable climate, possibly with liquid water and an atmosphere that was thick enough to support life. But something happened, likely a series of volcanic eruptions that would have caused the atmosphere to change drastically. Volcanoes can spew out gases, lava, and ash that can actually choke a planet's air, leading to extreme temperature shifts. Over time, these eruptions could have pushed Proxima B's climate into a tailspin, with some areas boiling under the heat, while others were plunged into freezing cold. All that volcanic activity might have been followed by global cooling, freezing its oceans and making the planet nearly impossible for life to thrive on. The once promising liquid water would have turned into giant ice sheets. Now imagine we could dig into these frozen oceans. What if deep under the ice, in pockets of water that were protected from the harsh environment, some kind of life managed to survive? It's not totally out of the question. After all, life on Earth survives in places we thought were impossible, like deep sea vents, where no sunlight ever reaches and where the pressure is crushing. If we could reach these areas on Proxima B, we might find something similar. Maybe there's life frozen in the depths, or even just traces of it, preserved for millions of years. If we can somehow warm things up enough to thaw the planet's oceans and restore some balance to its atmosphere, we might have a shot at seeing what Proxima B could have been before the volcanoes and the extreme temperatures wiped it out. Hunt for answers. Those mysterious light emissions from Proxima B's dark side are the kind of thing that keeps scientists up at night. They don't behave like natural light caused by a planet's atmosphere or reflected starlight. These lights are different, That's why researchers are wondering if they could be coming from something artificial, maybe even alien technology. If that's true, then we might be on the edge of discovering intelligent life for the very first time. Just think about that. Not just microbes, not just water or bacteria, but a fully functioning civilization. What would they be like? Would they even look like us? Could they communicate? Would they want to? These are the kinds of questions that move this conversation from science fiction to scientific urgency. Even if the lights end up having a natural explanation, they're still opening our eyes to how little we truly know about other planets. They might reveal new weather patterns, unusual atmospheric chemistry, or energy sources we've never even considered. Either way, they're important. But here's the challenge. Proxima B is over 4 light-years away, and we don't yet have the tools to get a clear look. Our best telescopes, like the James Webb Space Telescope, are amazing, but they still struggle with the distance and interference from Proxima B's host star, a red dwarf that spits out solar flares and intense radiation. These flares can mess with the signals and make it harder to study the planet accurately. That's why scientists are counting on future technologies, like the Harmony instrument that will be part of the extremely large telescope. This next-gen tool could change the game, giving us a sharper view and better data about the planet's surface, atmosphere, and possible biosignatures. If these new tools confirm water, organic materials, or even more of those strange light emissions, we'll be one step closer to answering the biggest question of all. Are we alone? Until then, every discovery, no matter how small, brings us closer. We hope you enjoyed this video. Stay tuned for more mind-boggling stories.